So we're going to take a look at exponential functions. Now what we're going to do is we're going to just explore this. Like I told my other classes, ideally...
Students and teachers, pardon this interruption.
Ideally what we do is I would give you this worksheet and I would let you guys go at it and then figure out things. It's called exploration. The problem is that some of you would do that, but not all of you would do that. So we're going to go ahead and we're going to explore this together. What I mean by exploration is, rather than me saying a exponential form is y equals b to the x power. This is an example of exponential form. This is what we do. What we're going to do is you're going to look at stuff and figure stuff out on your own. So here we go together. We're going to do this. Independent variable x is expressed as the exponent. It is in the exponent to this time. This is our first thing that is different compared to most other of the forms that we've learned, the function forms that we've learned. So independent variable x is the exponent. Okay? So it's important that you know that. Because normally when we're talking about other functions, we talk about y equals mx plus b, and x is being multiplied to something. We're talking about y equals ax squared plus bx plus c. Again, x is being multiplied to something. In this case, the x is the exponent. Okay, x is the exponent. The form for the exponential form is y equals a times b to the x power. I don't like the dot. We don't use the dot anywhere other than random times in a textbook or notes. This is really what you'll see it as, y equals a b to the x power.
Wait, it's x.
I know, but I'm having a hard time. I want to make it look readable. There you go. Close enough. Okay, y equals a times b to the x power. So let's go ahead and jump right in and start looking at some tables. What is our a value right here? 5. Based on what we just learned, or what we can read up there, our a value is 5. What is our b value? 2. Let me explain a couple things for you real quick. One, okay, a cannot be 0. Okay? B is greater than 1.
Always.
Sorry. B is greater than, 1. Okay, always. Yes, because if B is 1, okay, 1 to any power is what?
1.
1. Right? So 1 to the 1,000th power is going to be 1, right? Okay? And then, if you have 1 to the 1,000th power, it equals 1. And then a is, let's say a is 5. 5 times 1 is 5. You no longer have exponential. You have a single horizontal line. So it can't be 1. So it's got to be greater than 1. Okay? And x is also going to be greater than 1. Okay?
A equals never 0.
I'm sorry, x is greater than 0. I said 1. 0. Yeah, a is not equal to 0. B is greater than 1, and x is greater than 0. Now, we're going to use x, and what I mean by x is greater than 0, that means overall. I can't just have 1 that says x is equal to 0, and that's it. Okay? So we're going to use x equaling 0 in order to help us find some stuff here in a second. All right, so let's go ahead and get started. Now, if a is 5, based on this, because a value is the first value, and b is 2. B is also classified b because it is the base. Okay? Now I'm just going to go plug in my values. I control the x values. These are independent. I control those. Just like in science, you control the independent variable. Same thing here. So if I take this 0 for x and I plug it in, where it goes in my function, oh, by the way, just a reminder, this is an H table, a little bit different than our T table. We use T tables more than anything else, but an H table basically says, here's your x, here's your y, here's how you get from x to y. So x, how do I get from x to y there? So you have an input and an output. Okay, so I'm going to plug in 0 for x. Okay, when I plug in 0 for x, I'm going to end up with y equals 5 times 2 to the 0 power. What is 2 to the 0 power? 1. Okay, 2 to the 0 power is 1. Any number to the 0 power is 1. You have to remember your exponent laws. So you've got to hold on to that. So 5 times 1 is 5. Go down 1. I have 1 now. Y equals 5 times 2 to the first power. 2 to the first power is? 2. So anything to the first power is the base. Okay, any base of the first power is the base itself. So 5 times 2 is 10. Then I take 2 to the second power, I get what? 4. 4 times 2 is 20. What is my next one going to be?
Y equals 5 and times 2 to the third power.
So y equals 5 times 2 to the third power. 2 to the third power is 8. 8 times 5 is 40. Okay? The next column. Y equals 5 times 2 to the fourth power. 2 to the fourth power is 16 times 5 is 80.
So they're just doubling.
Okay, right. They're doubling in this particular scenario. Now let's talk about a couple things. Let's compare this to linear for a second. If this was a linear table, because that's most of the time we spend a lot of time with in Algebra 1 are linear tables. If this was a linear table, what would happen is your x values would go up by 1. 1, 1, 1, 1. Then your y values would go up by the exact same number. 5, 5, 5, 5, right? If it was linear. This isn't linear. This is exponential. So we're going up by 1, 1, 1. But now we're going up by 5. Then we're going up by 10. Then we go up by 20. Then we go up by 40. And just like Trevor said, we're doubling in this particular scenario. That isn't always going to happen. But in this particular scenario, we're doubling. Okay? Now, let's take a look at our successive ratio. This was kind of my turning point when I decided the video wasn't going to work out. Because that term successive ratio is something that you guys may not be comfortable with. Successive ratio. Successive means in order, like in order. So if I was going on this line successively, it would be Gabe, and then Wes, and then Trevor, and then Karsten. It would not be successive if I said Gabe, Trevor, and I skipped Wesley. Successive means you don't skip anything. Ratio means divide. Okay, ratio means divide. So in this case, I'm going from my last number back and dividing. So 10 divided by 5. Okay, 10 divided by 5 is 2. Here, a last number and then back. Or this number and the previous number. So 20 divided by 10 is 2. What's the next column?
40 divided by 20.
So 40 divided by 20 equals 2. Next? 80 divided by 40 equals 2. So now we have our table exhausted, meaning completely filled out. Okay? So let's talk about what we can see in our table. Where does the A value appear in the table? Go ahead, Sarah.
It's what you're multiplying the B value with. You guys said.
Yeah, so it's the first term, right? It's the starting term. It's what you multiply the B value with. Okay? What else? Where else does it show up? Where else does the A value show up?
It equals the excessive ratio.
Successive ratio, not excessive ratio. So it's the starting number in our function, right? Starting number, and we're looking at the A value, not the B value. So where's the A value also at? But hold that thought. What is the A value?
5.
It was 5, remember? I don't know, I erased it, sorry. Okay? Where else do you see 5? So she said you see 5s right here.
In the Y column.
Okay, now you see it right here in the Y column. Okay? But more specifically, where do you see it in the Y column?
The very first one on 0.
Okay, so when X is 0. So, when X is 0, you see it in Y. So Y equals A when X equals 0.
So then would your A be your... Yeah.
Okay, very good. Because you guys are connecting that when your X is 0, you have what? A Y-intercept. So you have an X is 0, you have a Y-intercept.
But
So
exponential
now,
graphs don't have.
so now you have a Y-intercept because X is 0. And A is also your Y-intercept. Yes, that's true. Exponential or not, if X is 0, that point is on the Y-axis, right? It doesn't matter if it's exponential, quadratic, or if it's a sine wave or anything else. If it has x being equal to 0, that point is on the x-axis, on the y-axis. So yes, that would be a great observation that your a value now is your y-intercept. Okay, and we'll talk more about that in a second. Now, what is your b value up here?
2.
Okay, your b value is 2. Where does it appear at?
On the successive ratios and on the equation.
So it's, okay, let's talk about the equation part first. So you see it here in all of these. What is this called again? The base. So it's your base in your equation. And then you see it again in your successive ratios.
Why do you do the successive ratios? Is it a checking?
Okay. It's interesting that you asked that. Why do we do successive ratios? Not checking. What this is, right now, remember I gave you all the information, right? So right now we have all the information to fill out that table. But in a minute, I might need to figure out some stuff on my own. Well, that's where successive ratios will come in. Okay? Let's go ahead and look at the other table for a minute before we make any conclusions, any real hard conclusions. Okay? Number 2, what is the a value there? 8. What is the b value?
1/2.
1/2. Okay? Same thing we did in the last table. Okay? If I plug in 0 here, 1/2 to the 0 power is?
0.
1. 8 times 1 is 8. 1/2 to the 1 power is? First power?
Base.
Is the base itself. So it's 1/2, excuse me. 8 times 1/2 is 4. 8 times 1/2 is like dividing by 2. Okay? If there's ever a 1 on top, just divide by the bottom number. Okay? If I plug in 2 for x, I have 1/2 to the second power. Yes, question.
Why that one over there they didn't put in parentheses, but this one over here they did? Because it's a fraction.
Yeah, good question. Okay, he's asking why did we not put the base over here in parentheses, but over here we did. Over here, 2 squared is understood to be 4, right? If you don't put this whole thing in parentheses, you might square just one part. This tells you that 0 goes here and 0 goes here. 1 goes here, 1 goes here. Okay? Just make sure that you square the whole term. Okay? So when I put 2 up here for my exponent, 1/2 to the second power is what?
1. Right?
Nope. It's 1 squared and 2 squared. So it's 1 over 4. So 8 times 1/4, or 8 divided by 4 is 2. Okay, what's my next line going to say?
8 times 1/2.
So y equals,
Yeah, y equals 8 times 1/2 to the 3rd power.
okay, and 1/2 to the 3rd power is?
Probably going to be
1 over 6. 1 over 6. 1 over 9?
2 to the 3rd power.
Oh, 6. No.
8. 8. 2 times 2 times 2 is 8. So it's like saying, again, remember you got to remember your exponent laws. It's like saying 1 to the 3rd power is 1. 2 to the 3rd power is 8. 1 over 8. Okay? 1 over 8. That's why you keep them outside the parentheses. So then you have 8 times 1 over 8, which is 8 divided by 8.
1/8, right?
No, 8 divided by 8 is just 1. And then your last column?
y equals 8 times 1/2 to the 4th power.
1/2 to the 4th power is?
2 to the 4th power is 16.
Yeah, 1 over 16. So 8 times 1/16, or 8 divided by 16 is? 1/2. Okay, let's take a look at our successive ratios. Okay, again, going backwards. 4 divided by 8, 1/2. 2 divided by 4, 1/2. What's the next one going to say? 1 divided by 2, which is? 1/2. No different there. And the next one? 1/2 divided by 1. Okay, anything over 1 is itself, so 1/2 divided by 1 is 1/2. Okay, so let's take a look at this again.
Successive ratios always equal the exact same thing?
Yes, yes. Successive ratios should always, if you're dealing with exponential, should always be the same. Yes. Okay, now, where does the a value appear in the table again? Let's make some conclusions now. Not first term. You don't say first term, because first term could be x equals 37.
It equals
No.
the first y over there.
Not always. Where's A value always? You can always say that.
When x equals 0.
When x equals 0. That's huge. What if 0 is not in the table? You see what I'm getting at? You guys are saying the first area. Some of you guys are saying, well, the first y value, the first line. That's not true if x isn't there.
Yeah.
So sometimes your table can start with 72. So it's wherever your x is 0. So A is still where your x is 0.
But why wouldn't your A always be the first number?
Because because that's just how they do it. Here's a table with 7, 8, 9, 10. You know, figure it out. Kind of a deal. Okay? Now, you may always make it 0, and that's fine, but not everybody. Okay? So where does the A value appear in the table? Again, where x is equal to 0. Where's the B value appear? And it's also still the starting point. That doesn't change, but now we've made a better conclusion. Where does the B value appear in the table?
Successive ratio.
Again, it's a successive ratio. And that's just random coincidence. Successive ratio. So let's make some conclusions then. You've already done this earlier. You said A is the y-intercept. You made that conclusion. Is A always where x is 0?
Yes.
Yes, it is for exponential. What about B? B is always the successive ratio. So knowing that, if I know B and ask me for the successive ratio, I can just say, hey, the successive ratio is 2. No math needed, right? If I know B. If I don't know B, but I have a table, can I find the successive ratio?
Yes.
Yes. If I can find the successive ratio, I can therefore find B, right?
Oh, wait. How can you, if there wasn't a B up there, that would just, what would that be 8 times?
No, see, okay, here's the deal. Again, you're looking at the fact that I've given you everything.
Oh yeah, those are in order. It would just be out of order, but the B would still be there, right?
No, what I'm saying is, what if I just gave you a table that had a T table? Take the H part out, and you're taking a test, and I just gave you a table that said 0, 8, 1, 4, 2, 2.
Well, I would know that the A value is 8 if x equals 0.
Right? I would know the A value is 8 because x equals 0, and then I would find B by doing what? Using the successive ratio.
Oh, yeah.
Okay, so we're going to do more of that in just a second. Okay, so now, let's make some comparisons here. So we've just talked about them being the same. The A value is where x is 0, that's both the same. The successive ratio is where is B, that's both the same. But what makes these different?
One of them's doubling, one of them's half.
Okay, so one of them is going up, or what's another better word for up? Increasing. One is increasing. I don't want to hear positive and negative the rest of the class period because that has nothing to do with anything right now. So one is increasing, and one is decreasing. Now, let's take a time out from exponential for a second. Actually, not a time out. Let's go back in time for a second and remember, what do we know about exponential already?
Never touch the x-axis.
Never touches the x-axis. Okay, what else do we know? There's 2 types. They are, and they have to do with increasing and decreasing. What are the 2 types called? Might have heard this in science a little bit too. If something is increasing, what are you doing? So you have exponential growth and exponential decay. So don't forget about that. So what does this first table represent? Exponential growth.
Okay. You can stop right there, man.
What about this one? Decay. Now, so the clear observation is one is going up or increasing, one is growing, one is going down or decreasing or decaying. Now, where do you think that comes from?
Increasing and decreasing.
The B value?
Okay.
Oh, yeah.
It's coming from the B value. Okay? So, Wes made the observation that he thinks it's coming from the B value. So tell me specifically what the B value does in specific patterns. If B is this, then B will do that. Or then the graph will do this.
Okay, if B is a fraction.
If B is a fraction, it is decreasing, or it is
Decay.
decay. If B is...
Whole number.
Okay, now hold on about the whole number part. Can I have a fraction that has a whole number?
Yes.
Yes. So how would I say any number that's not just a fraction?
So any number plus
Any number greater than 1 is going to give me what? Growth. Right? So a number greater than 1 is... So B greater than 1 gives me growth. Now, I have to revise my decay statement then, because it can't just be a fraction.
So it's less than 1.
B is less than 1 but greater than 0. So B is between 0 and 1. Right? Any number between 0 and 1 is what? A fraction.
But I thought you said, like, at the beginning of our notes, B is greater than 1. Didn't you say that?
Yes.
B is... Oh, I said B is greater than 1?
Yes.
Oh, my mistake. Not B is greater than 1. X is greater than 0.
So B is greater than 0?
No, B is, okay. What I was trying to get you is B is not going to be, don't worry about that. Don't worry about that part. I don't want to confuse you. Don't worry about that part. So take out the B. If I put B is not supposed to be, if B is supposed to be greater than 1, take that out. Sorry. I didn't mean to write that up there. Okay. So we've made some conclusions about our graphs from there. All right, let's keep going through our questions. And some of these questions you just answered already.
To determine the A value from the table, what mean must be the value of x 0?
Okay?
1.
So again, for somebody else, if I wanted to determine the A value, okay, the A value from the table, what must be the value of x?
0.
Okay, 0. We already said that several times, right? So x must equal 0. If x equals 0, then y equals a. How are the successive ratios calculated from a table?
By dividing the x values.
Not x values.
Y values. Sorry.
Y values. So here's how I'm going to write this. Dividing the next y value,
By the previous y value.
yes, by the previous y value. Okay? So dividing the next y value from the previous y value. How did the successive ratio calculated in the table compare to the b value in the algebraic rule? Algebraic rule is another way to say function or equation. They are the same.
What is algebraic rule? Another thing for what you said?
Equation or function. Okay, any questions to this point? Okay, number 6. If only a data table of x and y values, and this is what we were talking about a little bit earlier, if only a data value table of x and y values for an exponential function was given, how would we determine the algebraic rule? Okay? So, you know that a equals y
When x is 0.
when x is 0. Okay? And then you could do what?
Go to successive ratio.
And then b equals successive ratio.
Is there like a symbol for success?
No, I wish.
Zeros. I hate writing.
It's good for your spelling and handwriting. Hasn't helped mine at all.
I like that zeros a lot better.
Okay, now let's take a look. Let's put this into action. Okay, so if I have x and y, and I have 0 and 5, and 1 and 10, and 2 and 20, and 3 and 40.
So basically,
2, 20.
Okay, what's our function?
5.
What's the initial, our setup?
Y equals
Y equals
5.
a
Oh, yeah.
b to the x. That's all I'm asking for right now.
Okay, that's
Okay, now, what do we know a is right now?
5.
5.
5. What do we know B is?
10 divided by 5 is 2.
10 divided by 5 is 2.
Yes, some maths.
Or you can check to double check. 20 divided by 10 is 2. So B is 2. So now what is my function?
Y equals 5 times 2x.
Y equals 5 times 2 to the x power.
How come you didn't put x outside the parentheses?
It doesn't make a difference when the numbers are whole numbers.
Oh. Killed it.
Zeros?
I mean, you can go either way. It doesn't make a difference.
Just touch them on the chin.
I mean, that's really redundant anyways to have parentheses. There's no... Okay, here we go. Let me show you this real quick. Before we move on, I want to show you one other thing. Okay? Let's say I forget what successive ratio is. Let's say I forget that I can find my B value as my successive ratio. Well, one thing you could do is say, okay, you know what? I know A is 0 though. I know A is where X is 0. So that's not a problem. That's stuck in my head. I get it. So now I say, okay, I know that Y, or that A equals 5. Would you stop? Okay? So now, if I did this and I have the table given to me, I could say, okay, Y is 10 when A is 5, because we just figured that out. I remember that. I don't know B, but my X value was what? 1, right? So I got all this information for this particular function, or part of a function, from the table. 10 was my Y value, 1 was my X value, 5 I knew because I just remember that, but I can't remember how to find my B. Can I solve this algebraically? Yeah, because what is B to the first power? B, so B to the first power is B, so 5 times B. Now do what? Divide by 5. So B equals 2. So it still works out algebraically as well.
If B was like 2 for like the next one, would you just like if divided by 5 and then B squared, you just find the square root?
Yes. Yeah, listen real quick. She brings up a good point. Well, what if, she said, okay, well, what happens if I accidentally use 2 because I'm afraid of using 1? Because a lot of times using 1 gives you a kind of a false answer. So she said, what if I didn't use 1 because I don't want to make sure that wasn't messed up, so I used 2. So she puts 20 here equals 5B squared. Okay, well, if I want to solve for B, I got to get B by itself anyway. So so I would, well, I lost my train of thought. 20 equals 5B squared. So what I'd have to do is, I'd have to do the square root. And so what you'd end up with is 20 divided by 5 is what? 4. So you have 4 equals B squared. Square root of B gives you, square root of B squared gives you B. So you square root one side, you got to square root the other. So square root of 4 is 2. Still the same. Okay? Anytime you square root a square, it cancels out the square. Yes. So x squared square root is x. And so on and so forth. All right.
Jeremiah, you're all so half my size, you bass.
Okay, here we go. Now the next part just says that we're gonna graph these and take a look at the graphs. Because we already have a table, right? Whoops. Okay, let's take a look. We already have the tables because these are the same functions as before. So let's go ahead and graph them. All right, so what we're going to do on the side here, we're going to have 0, 10, 20, 30, 40, 50, 60, 70, 80. Over here we're going to have 1, 2, 3, and 4.
How come you skipped?
Just because I can spread the graph out the whole page. Okay, so when x was 0, what was y? On our first function.
X, 5.
Okay, 5. Not there. Somewhere in there. Okay, when x is 1, I'm sorry, yeah, when x is 1, y is what? 10. When x is 2, y is 20. X is 3, y is 40. X is 4, y is 80. So here's our function. What can you clearly see now? Which is called? Growth. The curve indicates that it's what? If I didn't have an equation to go with this, the curve indicates that it's not just growth, but it's what you said, exponential growth. That's the exponential curve. You remember from when we did that whole thing before. Okay? So I can clearly see its growth now. Okay? Let's look at the next one.
So from a graph, you could figure out the table, and then you could figure out the A and the B too.
Yeah, we're going to talk about that in a second.
Oh, yeah.
Okay, now, let's look at the next, let's go ahead and graph the next one. So now I have, on this one, I'm just going to go ahead and do 0, 1, 2, 3, 4, 5, 6, 7, 8.
How come?
Because the highest number I have in my table was it 8? Yeah, 8. So over here, I'm just going to do the same thing. 1, 2, 3, and 4. So when x is 0, what is y? 8. When x is 1, y is?
4.
When x is 2, y is? 2. When x is 3, y is? 1. When x is 4, y is? Half. I'm having hard. Okay, so our function looks quite like this.
Quite.
So this is exponential decay. Exponential indicated by the curve. And then, of course, decay because it is decreasing, right? Okay. Now, where does A value appear in these graphs? And we've already talked about this. Yeah, you guys figured this out from the table. The A value appears in the graph at the y-intercept. And that happens in both graphs. Which is why when x is 0, that is your A value. Okay, that solidifies that notion. How does a B value appear to affect their graph? And we've already talked about this as well.
It determines your growth or decay.
It determines if it's growth or decay, right? Okay, what determines growth again?
Growth is greater than 1.
Growth is greater than 1?
Decay is between 0.
Yeah. Okay, so decay is between 0 and 1 or greater than 0 and less than 1. Okay? So on this one, I'm going to put growth.
So can you not have a negative B?
Because B is greater than 1.
Zeros.
You can.
Would it just be flipped then?
Okay?
Just be on the bottom.
Yeah, we'll talk about that later, but you can. And then decay over here. And it's because between 0 and 1.
0 and...
Okay, how can I find my successive ratio?
Your successive ratio.
You
Okay,
take
you
the
can
points
take
and
the
you
you can take
divide
your
the Y value.
this axis and
Yeah, he said this axis being the y-axis, y value. So take your y value, like here. What's my y value here?
1 half. Or no, 5.
5. What's my y value here? 10 divided by 5, right?
2.
2. 20 divided by 10.
2.
2. 40 divided by 20. So on and so forth. Same thing over there.
Right there, 0, 1.
Yeah, there's my A at the y-intercept, right? All right, let's go. Let's move on. Let's look at number 9. How could the graph of the exponential function be determined to be used to determine the A value? We've talked about that several times. How can I look at my graph and find the A value?
When x is 0. Or no. Yeah, when x is 0, right?
Yes, but on a graph.
When it hits the
Yeah, it is the y-intercept, right?
It is the y-intercept.
So A is the y-intercept. How can you determine from the graph if the B value is greater than 1? Or if it's a fraction between 0 and 1?
It decays.
Okay, so growth tells me...
It's higher than 1.
So growth is greater than 1. So B is greater than 1. and decay is B is greater than 0 but less than 1. That's how you would write that. Growth and decay. Okay, so if only a graph of an exponential function was given, that means you only got to see the graph. How would I come up with the algebraic rule? Or how would I figure out the function or the equation?
The 2 steps.
Yeah, the 2 steps we just talked about. A equals y-intercept. B equals
The y divided by y. For successive
still the successive ratio. And you guys looked at the y values on the graph, right? Dividing them appropriately, the last one by the previous one, or the next one by the previous one. And then you just simply plug in, right?
Or you just know the answer like me.
Okay, so let's make sure we understand this fully.
Come on. I understand it.
12, number 12. Okay, what is our A value?
2.
Okay, how do we know?
Because the x is 0.
X is 0, right? So my y is 2, so I know my A equals 2. What is my B value?
Yeah, 3.
How do I know it's 3?
Because 6 divided by 2.
6 divided by 2, 18 divided by 6, 54 divided by 18. All those, again, dividing, in this case, the one below divided by the one above. So B is 3. So what's my algebraic rule?
Y equals
2 times 3. 2 times 3.
To the x power.
Okay, how do I know, what do I know before I even do anything on this? What kind of graph is this?
it's going to be a growth.
It's going to be growth. How can I tell?
It's increasing.
What's increasing?
The y value.
Y values. I said before I did my algebraic rule, when I look at this, I know that my Y values are increasing, so it's going to be growth. What about number 13? Decay because
It's going less than 1.
they're decreasing, right? Okay, so what is my A value? 250. What is my B value? 1/5. 250 divided by 50 is 1/5. An easier way to find that is 10 divided by 50. Cancel out the zeros. You have 1/5. Okay. Or 2 divided by 10. If you reduce that, it's 1/5. So in any case, B is 1/5. So what is my algebraic rule?
Y equals 250 times 1/5 to the x power.
Okay. Any questions on either one of these? All right. Let's look at, and you guys are going to do this on your own, 14 through 17.
We got a row.
No, you don't have to. I'm just helping you identify some things.
You just want to direct the equation.
Yeah.
Yes. I'm going to pass your homework out to you, but we're not done. I want you to understand that we're still going to cover a couple more things. So I need you to stay focused for just a minute. So number 14. Okay, what do we have here?
Decay.
Decay, how do I know?
Because
It's decreasing. What is my A value?
256.
Okay. What is my B value?
140.
Okay. So what's my function?
Y equals 256 times 1/4 to the x power.
Anybody disagree with that? Okay. Any questions on number 14? Number 15. What do I have? Growth. How do I know?
Because it's increasing.
Increasing. A is.
5.
B is.
5.
So what's my function?
5 times
Y equals.
5 times 5 to the x power.
x.
Any disagreements there? Any questions there? Okay. Number 16.
Growth.
Okay, growth. That's clearly evident by the graph, right?
Increasing.
Okay. What's my A value?
1.
What's my B value?
2.
Okay, so what's my algebraic rule?
Y equals 1 times 2x.
Or, more simple than that,
2 to the x.
Y equals 2 to the x power. I don't have to write the 1 because 1 times anything is itself, right? Okay. What about the next one? What do I have? Decay. Okay. What's my A value?
81.
A equals 81. B equals
1/3.
1/3. So I have Y equals 81 times 1/3 to the x power. Any questions on that? Okay, last thing I want to talk about is domain and range. What's the domain here? What?
What's a good way to like remember that domain is x and range is y?
Domain and range is x and y.
Or because I get them mixed up like all the time.
Done memorization.
Domain is your x.
Well, he knows that. He wants a good way to know how to remember that. Just straight memorization. Huh? Alphabetical, right. D and R, X and Y. Very good. Never thought about it. I just knew it. So,
Or D, we're down.
oh, down on the bottom.
Yeah, boy.
I think she trumps you alphabetically. That's pretty good. Sorry.
I doubt it, y'all.
All right, here you go. So domain and range. So what's my domain here?
Wait, where?
I'm sorry, on number 17.
1, 2, 3, 4.
0.51.
Okay, remember how we find domain and range? Is there a minimum? X value. Does X go to the left? Does it ever stop going to the left?
No.
Well,
Yeah,
Well, then
at
it
81
is
doesn't
on
it?
it.
Yeah, it does stop going to the left.
It just goes straight up.
so it's
And it goes straight up.
0.
Okay, so X has to be...
Less than 81.
No, because you're thinking of Y.
Oh.
X is what?
Greater than or equal to 0.
No. Why is it not equal to 0?
Because
Oh.
exponentials never.
It never touched 0. So my domain is X is
Greater than 0.
greater than 0, right? Because my graph is going to go this way forever. It's going to go forever that way. It's going to go forever up, but it's never going to go into my negative. Okay?
Wait, I have a question.
Yes.
If it's... Oh, no.
So X is greater than 0. That's my domain. What is my range?
All real numbers.
No.
But if it keeps going up.
Y greater than 0.
Y is also greater than 0, right? Because it's never going to cross my X or Y axis, right? So that means it's never going to go down here, so my Y value would be 0. It's going to keep going up forever, so Y must be greater than 0. Okay?
So on
Is it supposed to be like...
If it's domain.
so on exponential graphs, it never crosses the y-axis, but it can be on the y-axis.
Oh, I'm sorry, I screwed up on the domain.
So it is...
The domain is, it can cross the Y-axis.
So it is going to be...
Okay.
No,
Yes?
it's not going to be 0.
Well, no. The domain is going to
If
be
it can
0.
cross
The
the
X
Y-axis.
value...
What is the domain going to be? Not 0.
Then it's going to be all real numbers.
All real numbers, because if it can cross, it's going to keep going and going and going and going.
Alright.
But you're right, it will hit 0. It's all real numbers, my mistake.
So it was...
messing up my brackets. Oh well. What about over here? What's the domain?
All real numbers. But that's,
Does it keep going this way? Yes. Will it keep going this way? Yes. So my domain is? Whoa.
that's what it said.
What, but there's no arrows on the graph.
There's no port.
Oh, you're on
Here you go. Feel better now?
Yeah.
Okay.
Y
Range is?
Greater than zero.
y is greater than 0.
Y is greater than 0.
Is that all exponential?
These particular forms, and this, if you're in quadrant 1, because you're starting and you're dealing with a lot of stuff in quadrant 1, and this is going to roll over to quadrant 2, but never go down that bottom half. So it's all positive, right? So all of my y values are positive. There are going to be times where you'll see, and I don't know how much you'll see it this year, where you'll see an exponential going down here. Okay, so that is a possibility. Okay, so make sure you understand domain and range because that will pop up. But domain is almost always, I'm never going to say always, almost always all real numbers. Okay, if you have to guess all real numbers for domain. All right, any other questions?
Yep.